So we are looking at one-step equations now, adding and subtracting, and we're also going to do multiplying and dividing. And so some things we want to focus on today is to solve one-step equations using the subtraction property of equality, and then solving one-step equations using the addition property of equality. Okay, and then also using solving real-world mathematical problems with one-step equations, adding and subtracting. Okay. One thing I want you to understand about the term equation. An equation is a sentence stating that two quantities are equivalent. Okay? They're equivalent. They're equal. Okay? So when we look at the addition property of equality, it says the addition property of equality states that the two sides of an equation remain the same when you add the same number to each side. And the subtraction says that it states that two sides of an equation remain equal when you subtract the same number from each side. Okay. So let's look at my I do right here. I have x plus 5 equals 9. Okay, so what camera today? Oh. So what they're saying right here is x plus 5 equals 9. Now knowing that we have two quantities, okay, and separated by an equal sign, so they're equal. So x plus 5 equals 9. And so, of course, many of you already know what x would equal, but we are going to perform, we call it the inverse operation. I know we've talked about, I'll say, what's the inverse operation of, say, addition? It's also known as the opposite operation, which would be subtraction. So I'm going to subtract 5, my constant 5, from both sides, okay, so that my quantities remain equal. And then I have 5 minus 5 is 0. So I'm going to rewrite my variable x equals, and then 9 minus 5 is 4. Okay, so I have balanced my equation. Both sides are still equal. Let's look at our redo. We have 14 equals x plus 7. So the inverse operation of addition is subtraction. So I'm going to subtract my constant 7 from both sides. 14 minus 7 is 7. Bring down my equals and my x, my variable. So now I know that x equals 7. Then I have 4 plus x. Ooh, okay. Something's up with my camera, and I'm so sorry if you're getting dizzy. 4 plus x equals 15. So the inverse operation of addition, again, is subtraction, and I'm going to subtract 4, my constant, because I didn't say earlier, you want to isolate your variable to figure out what it actually equals. And I'm about to put 5 there and be exposed. Okay. So 4 minus 4 is 0. You don't have to write 0. X equals 15 minus 4, which is 11. Okay. I didn't circle either or highlight. Now, if you are not with us today or you're working independently, you need to complete these 4. You do for addition. Okay. So let's move on. Oh, wrong page. Wrong page. Wrong page. I gotta get it together, friends. This is my next page. Okay. Now, I'm just moving into decimals now. And you can use your calculator, okay? You can pop that out. I don't know why my camera hates me today. Okay. But, and I want you to emphasize the decimals because they are rather small. 2.5 equals x plus 1.4. So again, I want to isolate my variable x, so I need to get rid of 1.4. The inverse operation of addition is subtraction, so I'm subtracting 1.4 from both sides. And remember, when we are adding or subtracting decimals, we line up the decimal, okay? So 5 minus 4 is 1, 2 minus 1 is 1, and I'm bringing my decimal down, so x equals 1.1. So on my you-dos, I need you to do those independently, but I'm just going to come over here and emphasize the decimals. I hope you're still watching and not fast forwarding. And I just hope you're listening too. I hope that you have your sound on. So that's actually 15, 9.9, 16.2. Okay. So now that we've done the inverse of addition, we're going to move down to subtraction. Okay. So we know the inverse operation of subtraction is addition. Okay, and I have x minus 3 equals 2. So the inverse operation of subtraction is addition, and I want to isolate my variable x by performing the inverse, which is adding. So I'm going to add 3 to both sides because we're going to continue to keep my two expressions equivalent. So negative 3 plus 3 would be 0. So I bring down my variable x equals 2 plus 3 is 5. Okay. And then, whoops, I need you to do these four on your own, and they're all whole numbers. Last page. And over here, I have decimals. So what I'm going to do, what this you do, or we do, I have x minus 2.7 equals 8.3. So the inverse of subtraction is addition, so I'm going to add 2.7 to both sides. Now remember, when we add decimals or subtract, we line up the decimal. Now, of course, in this example, you can use your calculator because at this point, if you were to see a problem like this on TCAP, the goal is to understand balancing your equations, okay, balancing the equation. So both sides are equivalent, so you could use your calculator to add the decimals. So I get 11. So x equals 11. On these you-dos, you need to do independently to show me these are your decimals. Making sure, because the decimals are very faint. And yeah, there we go. All right. So next, I love these things. My real world problems. Okay. we have this information to solve these real world problems. We have Amber's age, Crystal's age, and Ethan's age. We want to know Benjamin, Doug, and Farah. So Crystal is 3.5 years older than Farah. How old is Farah? So Farah, we want to know what Farah is. Farah plus 3.5 gives me Crystal's age. Okay, and I know a lot of you would just want to put these two on one side together and say 16.2 minus 3.5, but the idea is to build an equation and then solve it. That's the hard part. So if I take Farah's age and I add 3.5, I will get Crystal's age of 16.2. So the inverse operation of addition is subtraction, so I'm subtracting 3.5 from both sides, and I am lining up my decimal. Okay. Now, if you have your calculator handy, you can go ahead and subtract. Mine's not, so I'm just going to work it old-fashioned. 12 minus 5 is 7. 5 minus 3 is 8. 5 minus 3 is 2. I know you're all like, wait a minute. 12.7. So Farah is 12.7 years old. Okay. Here are my two you-dos right here. Okay. We'll do these together. Ethan is 4.2 years younger than Benjamin. How old is Benjamin? So Benjamin B minus 4.2 gives me Ethan, which is 4.8, because Ethan is younger than Benjamin. So Benjamin minus 4.2 gives me Ethan's age. So the inverse of subtraction is addition. And so Benjamin is 9. I guess I should put that up here. Benjamin's 9. Farrah is 12.7. And then Amber is 7.3 years older than Doug. How old is Doug? So Doug wow. So Amber plus 7, Doug is, nope, I had a moment. Amber is older, 7.3 years older than, yeah, that is right. Doug plus 7.3, yes, is Amber. Having a moment here. So I'm going to subtract 7.3 from both sides. And I don't have my calculator. But look, it's going to be pretty. And not really. Okay, 14 minus 7 is 7. So Doug is 7. Oh my goodness, look at me. Not even bringing the camera down. So Amber is 7.3 years older than Doug. So Doug plus 7.3 gives me Amber's age of 14 and a half. I subtracted because that's the inverse of addition to isolate my variable. And then 14.5 minus 7.3 is 7.2. So Doug is 7.2 years old. Okay? It's a thinker. I know. It's a thinker.